on NPI.
EYE on NPI brought to you by DigiKey and Adafruit. This week it is Microchip. Lady Ada, if you could just dive right in.
Yeah, that's right.
Kick it.
Okay, so this week we've got the MCP41 and 42U83. These are some really nice single and dual channel digipots with digital control, SPI or I2C. They did a really nice job with these pots. I'm probably going to make a breakout for them because they've got stuff like non-volatile memory, 10 bits, really good bandwidth measurements, and of course, variable values from 5K to 100K. Everyone knows potentiometers. You know them, you use them, you twist the knob, resistance changes. DigiKey stocks like 715,000 different types of potentiometers. I mean, like, they're so good at converting mechanical movement into an electrical signal. And they all pretty much, other than wire wound and some other kind of, exotic ones, the vast majority of them work the same way. There is, here's a pot that's been taken apart. On the very left and the very right contacts, there is a conductive material that goes around in a circle or goes in a line. And then in the middle, you see those little fingers. That's the wiper. And the wiper swings around and contacts the middle pin to a point between the left and between the right. And as you twist it, it goes from the very bottom of the resistance to the very top of the resistance. So, you've seen them as volume knobs, trimmers. There's surface mountable potentiometers like these where you use little, Phillips or flathead screws to adjust them. And, people use them a lot. I use them a ton all the time to trim values, to adjust settings. They're inexpensive. They're easy to use, but there are some downsides. One is they are susceptible to mechanical failure. Like, I found this cool video on how to revive old stereo systems and ham radio equipment that has pots that go bad, because eventually that ceramic material can flake off. It can get scratched off by the wiper. Their oil or gunk can get in there because they're not usually sealed. So they do have a lot of failures. And if you have trim pots, if they're vibrated, they can come loose. People often would use a little bit of glue or something to keep them from moving around. And so there's also times where, you want to maybe adjust an analog voltage or resistance, and you don't want to tell people, okay, open up the case and get your potentiometer, little knob and twist it. So instead you could use a digital potentiometer, and this kind of works the way you think. You basically get, you power it with, 2.7 to 5.5 volts, and you connect to it over I2C, or SPI in this case is also available. And you basically tell it what value you want, and it will move the wiper. And inside there's like, this string of resistors, like literally there's 1,023 resistor terminals for every single one of the 10-bit values. That's why it's kind of nice, because sometimes most potentiometers kind of top out at 7-bit, but this goes up to 10-bit. This one can do also split supplies, although the total amount of supply between VSS and VDD still has to be under 5.5 volts. So it's not like a wide voltage range, but you can do split supply for analog voltages, split analog projects. And one thing that I thought was kind of nice is low total harmonic distortion, low noise density, especially when you're talking about the 5K or 10K value. And the bandwidth is really good too. You can get like tens of megahertz through here. So this is fine for, low grade radio, not super high speed, but, like tens of megahertz. Audio for sure, filters, sensor signals. So it's a great way to replace a potentiometer. What's nice is also with the 10-bit resolution, you're going to get more repeatability and accuracy than with a trimmer. Like, you're not going to be able to twist a trimmer to 1/1000th of its value, whereas you can tweak this digipot to 1/1000th of its value. To communicate with it, you send messages over I2C or SPI. It's a standard SM bus interface. There's both RAM, like dynamic memory, and non-volatile NV memories. So for example, you can write a value potentiometer, and then when the product starts up the next time, it's automatically set to the value that it was set to before. So, you immediately synchronize to the whatever you set the trimmer to before. One note, it does have a maximum write life of 1,000 times. So it's not like you can write to permanent memory on every twist if there's like a volume knob, but you can set it, when you like are about to power off or something, or maybe once every few minutes, or if the trimmer's only set in the field or to account for like temperature, humidity or something, 1,000 times will cover you. It's available in both TSOP and QFN. This is the single. There's also the dual, same package, just, the non-connect pins are a separate potentiometer. And all the variants are in stock right now at DigiKey, so 5K up to 100K. TSOP, QFN, single, dual, they're all available. But, you want to start with one, start with, I think, what did I pick out here? This is like the 10K QFN. I think this is what I would start with. A nice, low cost, under $2, and easy to pick and place, easy to use. Microchip has a great data sheet. I went through it. It explained everything very well. And
high praise.
The driver should be easy to write. So, I'll probably make a breakout for this, but check it out. I like the non-volatile. 10-bit is unusual. So very high resolution, high repeatability for a digipot. Check out the MCP41 and 42U83 83 series, available now at DigiKey.
All right.
EYE on NPI.